your work.
Yeah, no problem. So we're about a minute away from our start time, so we will um, hang on here, and then I'll make some introductions.
Hi, Jim.
Hi.
Hi, Frank. It's good to
Hello.
see you.
Yes, it's a pleasure. I'm checking how you guys are doing. This will help for us later on today.
Good plan.
All right. It looks like good morning. We've hit the top of the hour here, so we'll get a start. So I'd like to welcome everybody out. This is intended to be more of an informal question and answer session. Our program managers from DOE have joined us here, and I'd like to thank them for taking the time. What we're going to do is I have an introductory slide, maybe 2 slides here to go through. Then we'll turn our time over to our federal program managers, Jim Willett and Bill DeCola here to answer any questions that you might have surrounding the programs that they both manage, and asking any questions about the topic area work scope that we have. This is a new format that we've been working through from a topic area standpoint over the last 2 years. These topic areas are intentionally very broad. So if you've read through it as a potential applicant, you've probably already recognized, hey, this is everything under the sun or something like that, and that's intentional. In this format that we have, the intention here is to allow you to propose applications that are relevant to this topic area. Here, I'll just let me just mute everybody. If you wouldn't mind muting yourself if you're not talking, that'll prevent any feedback. But the intention here is to cover anything in the any mission space that's related to this topic area. So Ann, I'll have you turn to the next slide.
I want to mention that Frank Gollner is also a Fed, and he's part of the meeting.
Yeah, Bill, we do have. Thank you for pointing that out. Frank is here. He's part of the fuels group in the office, and he will be presenting later today. But wanted to observe how this meeting would go. So yeah, we'd like to welcome Frank, and I saw BP Singh just joined us as well, who's another federal program manager who'll be answering questions in our system analysis and fuel cycle analysis area. So let me go over, for those that are new to the Department of Energy Office of Nuclear Energy, the NE mission. This is what's guiding all of the applications that we're asking for in the CINR funding opportunity. So the mission consists of 4 different parts: keeping existing U.S. nuclear reactors operating, deploying new nuclear reactors, securing and sustaining our nuclear fuel cycle, and expanding international nuclear energy cooperation. So when we talk about this topic area, we'll have our program managers present, talk a little bit about the things that are ongoing in their program, provide us a very short introduction. But the idea is that if your idea fits within one of these mission areas and is within this topic area, which we'll put up on the screen in just a moment, then it would be a good fit for this area. I do want to note that there are certain topics that are not a priority for the Office of Nuclear Energy. These are topics that are covered in other agencies or other parts of the government. Things that are outside of any mission are medical physics, nuclear fusion, forensics, nuclear forensics, and environmental management. And so please do, if you need some clarification on where your ideas might fit within the mission, we'd like to entertain as much of that as we can, and let you know kind of where those dividing lines are between the fusion and fission world, where the non-proliferation and forensics versus some of the some of the radiation detection work that is relevant to the Office of Nuclear Energy is, those types of things. So as we go throughout the next week, for those that are interested, please ask questions surrounding this NE mission space if you're unclear about where NNSA mission space is versus Office of Nuclear Energy. Let's go to the next slide, Anna. So this is we tried to include the entire topic area here in this slide, so it's a little small, but I'll let Jim and Bill and BP talk a little bit about some more of these specifics, but this topic area 4 is finding ways to implement efficient, safe, secure, and economical nuclear fuel cycles that meet the needs for our clean energy future. And you can read through this here. I hope that you've already read through it to some extent. As we get right before I go to introduce our program managers and give them some time to talk about themselves and their own role, I do want to mention what the format is going to be here. So we'll have our program managers introduce themselves. Program managers, feel free to talk about what ongoing areas your program is investigating right now, any other things that you think would be useful for the group here to know. And then once our program managers have introduced themselves, we'll open a question and answer session. This is a 90-minute session for questions and answers. It doesn't have to take 90 minutes, but we've dedicated that time here to do so. So we'll take questions live, meaning that you can unmute your mic, introduce yourself, and then direct your question to a program manager or to somebody here in the university program staff if it's more of a question about the application or review process. So with that, we have our 3 program managers here. We have Jim Willett, Bill DeCole, and BP Singh representing the three programs that are associated with this topic area. And Jim, I'll turn some time over to you to make a quick introduction about the program that you manage, your background, any other words you want to put in there before we turn time over to Bill. Go ahead. Oh, you're muted. You're muted, Jim.
Sorry. Yeah, as Drew said, my name is Jim Willett. I'm relatively new to the Department of Energy, at least as a Fed. I spent a long time as a research scientist at Argonne National Lab doing molten salt, power processing, electrochemistry separations work. And right now I manage the molten salt and power processing activities funded through our office, as well as NEAP efforts and some other things as well. So let me just show one slide that kind of captures kind of pieces of things that we're, okay. Does that,
that's displaying. Yep. We can see it.
Okay, you can see, all right. I don't know if that helps or not. So there's molten salts have broadened their scope. It's no longer interest is not just as a process medium for doing electrofying, say, of spent fuel. It has applications in the whole molten salt reactor fuel cycle. So the synthesis of those salts, recycle of those salts, particularly the fundamental properties and structure of the molten salt solutions have been of particular interest to us in the last couple of years. The structure of particularly molten salts, as the uranium concentration gets higher and higher, become particularly important in terms of the thermodynamics and the thermophysical properties of the salt. When it's dilute, it's fairly simple, but once you get above 25 mole% uranium in the salt, it starts to form these bridge compounds, and that affects just a lot of the chemistry and the physical properties. We're using molten salts out in Idaho right now to prepare HALEU fuel. HALEU is high assay, low enriched uranium. That's planned for use in a lot of advanced reactors being developed. Looking at the back end of HALEU fuel coming out of a reactor, there's a lot of value there still. So there's molten salt separation processes, power processes that we could use to recover you spent HALEU fuel as well as advanced reactor fuels. And then even looking at spent fuel from Gen 3 reactors, recycling that. There's even non-nuclear applications of the molten salts, such as concentrated solar power, using these salts as heat transfer, heat storage media. So the real emphasis for this call, particularly, is in the more on the fundamental structure and properties. There's been a lot of modeling work going on. We funded originally one program looking at interfaces, molten salts with different metals and what's going on at that interface. And so it's in the past, as Drew said, things tend to be much more tied to specific programs. You kind of had to find somebody in one of the funded programs and partner with them. The scope has been loosened a lot. So we still want things that help us build a better technology. And a lot of that is understanding chemistry and structure of the molten salts at a molecular level, atomic level. It has to do it impacts with the solubility, with corrosion, so many other things. And we have the tools now to both model it and probe the structure with X-ray, neutron scattering methods, and spectroscopy as well.
All right. Thanks for that overview, Jim. Let's go next to Bill. Go ahead.
Very similar to Jim, I am relatively new to the being in Department of Energy Program Manager for NE, but I worked for almost 4 decades in the nuclear fuel cycle. And right now, I'm the program manager for aqueous separation and also for vapor phase processes for separation. And the main focus is the recycle and reuse of most of the fuel components in commercial and non-commercial fuel. And presently, we have about 90,000 tons of light water reactor EU fuel, and we have more than 20 companies that are coming in with new reactor designs and that will utilize different fuels. And we are looking at the legacy fuels plus any emerging fuel that will come into the market, looking at how we'll try to, once the fuel went through the cycle to produce power and comes out of the reactor, how can we treat that used fuel so that we can recover all the usable components and minimize the amount of waste that need to be disposed. In the case of light water reactor fuel, essentially 99% or so of the fuel, the U fuel, could be potentially recycled and reused, and that includes the circuloid cladding, the hardware that is the steel alloys, the uranium and other actinides, some of the fission products, including the noble metal one that can be valuable. And in order to do that, we need to use processes that can separate the different components and make into usable products. And in my case, I'm looking at aqueous processing and vapor phase processes like chlorination, fluorination, etc. And the goal is, like I mentioned, that we have a sustainable fuel cycle with a minimal amount of waste, so that we take care of producing energy, but also we take care of the a legacy that otherwise would be a waste and make it into usable product.
All right, thank you, Bill. We'll wrap up introductions for our fuel cycle group with BP Singh. BP, go ahead. BP, you may be muted if you're trying to talk.
I'm sorry. I was trying to get a website up, but just give me 1 second. Hold on.
Okay.
All right. Hi, good morning. Thanks for including me in this. So I'm the headquarters program manager for the Systems Analysis and Integration campaign. And in that campaign title, the word system refers to the entire fuel cycle from mining to disposal. And our campaign does a lot of work to develop and maintain the tools and capabilities that are required to analyze the entire nuclear fuel cycle. And you've seen in the text of the topic area 4 that our office that I work in is seeking to develop technologies that have the potential to reduce resource utilization, improve energy generation, and reducing waste generation, but improving resource utilization. And so we had done a study in our campaign, which was published in October of 2014, and I was trying to find the link for the website so I can put it in the chat. I'll put that in a little bit. So that particular study is quite relevant to the overall context of this topic, because we looked at the entire universe of fuel cycles that physics would allow you to construct in a technology neutral way. And we had the criteria kind of that are listed here, and we evaluated all the fuel cycles by grouping them into 40 groups. So I'll post that that link here. But generally, what our campaign does is it develops and maintains the tools and capabilities required to analyze nuclear energy system options to assist DOE in developing advanced fuel cycles and technologies, assessing technology readiness of the different technologies being developed, and communicating the role of nuclear energy in decarbonizing the economy and achieving clean energy goals, and evaluating the competitiveness and economic viability of nuclear energy. So we make projections using our capacity expansion tools on the share of nuclear for the future. And like, for example, right now we are looking at the impact that the recent acts like the Inflation Reduction Act and the Bipartisan Infrastructure Law have, and how they might impact the role of nuclear as it comes in future. As we try to achieve the goal of achieving a net zero economy. And recently we issued a report on the pros and cons of the HALEU, which is the high assay LEU fuel. That because there's a lot of vendors and reactors that are planning to use high assay LEU. So we wanted to look at it from a systems perspective. What are the pros and cons of that? And that report was just published and made available a couple of weeks ago. And last year, we did a coal to nuclear transition study, which got a lot of press and a lot of recognition. And in that, we looked at what are the potential benefits and challenges of siting an advanced reactor at a site or near a site where a coal plant might be retiring or may have retired. So that's just to give you a flavor of the kinds of things that we do. And I'd be happy to answer any questions or try to answer any questions that may come up. Thank you, Drew.
All right, thanks BP, and thank you for being here. I do want to recognize before we open up for question and answer a couple of individuals that we have on the call. Aaron Gravel is our team lead for the University and Competitive Programs team at DOE Office of Nuclear Energy. And we also have John Gilligan here on the call, who's the director of the NUP Integration Office. Aaron, John, any words you want to convey before we open up for question and answer?
No, let's hear the questions.
Okay, sounds good.
Yeah, likewise, Drew. Thanks.
Okay, let's get to it then. So like I said, format here is going to be if you'd raise your hand in the top kind of right hand corner, you'll see that you have a raise hand icon right next to your react icon. If you'll raise your hand, you can open your mic, introduce yourself. Please introduce yourself by name and the institution that where you work, and then direct your question to one of our program managers here. We'll keep the line open here as long as there are questions, and if we are ready to wrap up the conversation, we'll conclude earlier than our 90-minute mark. So with that, we'll open up questions to the general group here. Any questions on topic area 4 or any clarifications on the specifics of what the programs are doing in these spaces? Stephen, go ahead. You can unmute yourself.
Hi, this is Stephen. Oh, hello.
Hello, we can hear you.
Yes. Okay. Yeah.
ahead.
So, I guess a general question on this, since there are fewer topics and there are a few different areas. Is there any idea as to how many would be funded under topic area 4?
Yeah, I'll take that one. The the federal budget is still, you know, that process is still ongoing. So there's no real understanding of what the overall funding portfolio for the NUP program is going to be. The intention, though, is that multiple awards would be made in each of these areas, funding permitting, right? And so, so there's two aspects that we always put disclaimers on. The first is based on the quality of applications and based on availability of funding is how we ultimately make decisions about how many go in each area. The intention anytime we release a topic area is that we would fund at least one in each area and likely multiple.
Thank you.
All right, other questions? Yeah, go ahead, Stephen.
I guess I'll ask again for Jim. On so I guess from the FOA itself, it looks like there are interests in developing specific technologies or maybe gearing the research towards particular types of technologies, whereas your presentation kind of showed interest in general fundamental research. So I just wanted to confirm that, if we're proposing, for example, a new method that would generally apply to studying kind of fundamental chemistry, for example, is it important that we also have kind of a specific type of reactor or fuel cycle in mind for that?
I mean, you're somewhat familiar with this work from, I know, from other years. The we do need new tools to, I think, understand what's going on in the molten salts better. One tool I know in particular that's being worked on right now at Oak Ridge is a probe for the activity of the free chloride ion. It's a PCL, potentiometric probe. Measure the halo or the chloro acidity or chlorobasicity of a salt. Other ways to measure that, for modeling or even spectroscopic would be useful. I think that is one of the, in my opinion, one of the key properties is, or one of the key parameters that captures the degree to which complexation is occurring in the salts, rather than saying, I've got so many dimers, trimers, singly bridged. Okay, what is the PCL minus gets larger and larger, free chloride gets lower and lower, you'll have more and more of these structures. So the probes to look at that, or to do it in a fluoride salt, I think would be useful as well.
Thank you.
That's one example. Sort of the analogy, in aqueous systems, we have the EHPH, we have Porbet diagrams. We don't have the equivalent in a molten salt system. We can measure the redox potential, but there's a whole other axis that captures a lot of chemistry that somewhat orthogonal to the redox.
Thank you.
All right, thanks, Stephen. Thanks, Jim. Additional questions? I will note that BP has put the fuel cycle options link in the chat here if you're interested in the fuel cycle evaluation screening report that he was discussing earlier. All right, we'll keep the mic open here for a couple more minutes in case there are questions. And if not, then we'll wrap up our conversation. So if you do have questions, we'll let you kind of gather your thoughts here in the next couple minutes. And if not, we'll wrap up. Okay, not hearing any additional questions, we'll make a last call as I talk. So feel free to raise your hand as we go forward. One important aspect of the call that I want to point out to folks is that if you do have additional questions after this meeting, feel free to reach out to NUP@inl.gov. We will facilitate conversations with any of these program managers or any other individuals at DOE that you need to contact. Those could be clarifications on specific areas of research. They could be clarifications on the review process and the application process as it stands and written in the FOA. And I think you're all aware, but do want to remind you, end of the month is our due date for pre-applications, which are required to get through this the CINR funding opportunity review process. Those are due July 26th. So with that, yeah, go ahead, BP.
There's a question in the chat about if you're going to post the slides. You may want to look at that and answer that.
Yes. Yeah. Okay. Thank you, BP. Yes, we will gather up slides and we'll post those slides for folks to look at. So those should be available. We conclude all of these office hour presentations on the 17th. They should be available shortly after that. So with that, I want to thank everybody for attending. Thank you, program managers, for coming by and giving us an idea of what ongoing research areas you have right now. Like I said, if you have any further questions, please reach out to the NUP office and we will facilitate those conversations for you. Happy proposing, and we'll see all of you soon, I'm sure.
Thanks, Drew. Thanks,
Thank
everyone.
you.
Yeah.
Yep. Take care.
So Drew, what's going to be done with all the other ones as well? If you will just terminate the session, or is you going to leave it open if somebody else drops in later?
Yeah, we're gonna terminate the session now, and then we will. Jim, if you wouldn't mind passing your slide on to Anna, we
Okay.
can get